We've been studying a lot about circles, so today we're going to review some of the topics, and then you'll get to do an assignment over circles so that you're ready for your quiz on Monday. Okay, so let's start. We did problems when we had to find the measure of the arc, and then classify them as major, minor, or semicircle. And remember, when we did this, the most important thing was to look for a diameter. So here's a diameter. And diameters are good because they split the circle in half, which means you've got 180 degrees. So, since we know that this angle here is 165, this arc has to be 165, and this arc has to be 44, but we can find the other two missing ones by subtracting them from 180. So 180 minus 44 would give us 136. So this is 136 right here. On this side, we can do 180 minus 165, and we get 15. So this arc here is 15. Now that we've done that, we can answer whatever question they want. The first they want is arc DC, and remember it's two letters. It's the shortest distance between those 2 points, which would be that blue arc there, and we just marked that as being 136. Since it's less than half of a circle, it's less than 180, that makes it a minor arc. All right, let's do the next one. ABC. That means you start at A, go through B, and end at C. So it's a combination of two arcs. So it's a combination of the 165 and the 44. So when we add those together, we get a grand total of 209. That, however, is more than half a circle, so that makes it a major arc. Alright, arc BD, when it's two letters, it's the shortest distance between the 2 points. That's half a circle. Half a circle is 180, and that is a semicircle. Arc AC. Okay, two letters, shortest distance between the 2 points. So it's a combination of those two arcs. So it's 15 plus 136, okay, which gives us 151. Still less than 180, so it is a minor arc. Alright, last but not least, BDC. That means you're going to start at B, go through D, and end at C. So I could add up the three different arcs it's made up of, or I can do 360 minus 44, and 360 minus 44 is 316, so I get 316, which is a major arc. Alright, some more examples. Oh, word problem. Now remember, we don't even read the problem first. We draw the picture. So we have our circle, we have our chord, we have the distance from the center, which is always measured at a right angle, and we have the radius. Okay, the chord is 24 inches long, which is that whole length, and it's 9 inches from the center, and we need to find the length of the radius. Now remember, if we have a segment that goes from the center perpendicular to a chord, it splits the chord in half, so this is 12 and this is 12. So to find x, we're going to do Pythagorean theorem. So we have 9 squared plus 12 squared equals x squared. That's 81 plus 144 equals x squared. So we get 225 equals x squared. Take the square root, so x is 15. It's a word problem, so don't forget to label 15 inches. Alright, next example. Any segment that appears tangent is tangent. Well, we've got a rule that if there is a exterior point and we have two tangents tangent to the same circle, then these two are equal. Or if it looks like a clown, then the sides of its hat are equal. So we have 3x squared equals 75. Now if we had an x squared and an x, then we'd want to do a factor. But in this case, we're just going to isolate the variable, divide by 3, so x squared equals 25. Take the square root, and don't forget it's not just 5, it's plus or minus 5. All right. On this one, any segment that appears tangent is tangent. So that means that at the point of tangency, we know we have a right angle. So knowing that, we can set up the Pythagorean theorem. So we could have 18 squared plus 24 squared equals, well, we don't know what the whole length is. That's what we're trying to figure out. We know this part is 18, so we could say that it's 18 plus x. But that's kind of complicated. So instead, we're just going to call this whole thing y. Because once we know y, if we know this part is 18, then we can subtract it from whatever y is to get x. Okay, 18 squared is 324. 24 squared is 576. Add those together and you get 900. Take the square root, and so y becomes 30. But that doesn't answer our question. We need to get x. And to get x, we're going to do 30 minus 18. So we can find the missing part, which is 12. And that's our final answer. Alright, more circle problems. Oh, example 5. This is always a tricky one. Okay, but we can do it. If you're looking at the problem and don't know what to do, try drawing a radius to form a right angle. So if I go from the center and I draw in a radius perpendicular to the chord, that's helpful because I know it splits the chord in half and it splits the arc in half. So now instead of the arc being the whole thing 120, the two halves are 60. This is also helpful because this, with the vertex on the center, formed by two radii, is a central angle. So the angle has to match the arc. So this here is 60 degrees. So what we created is a 30, 60, 90. And you were given the long side, which is 2a. So we divide by 2, so the short side is 7, and the medium side is 7 square root 3. That only gives us half of the segment. The other side is 7 square root 3. So we're going to have 7 square root 3 plus 7 square root 3 to give us 14 square root 3 meters. Okay. I don't know why there's 288 there. Just pretend there's one. So we're trying to find arc AB. And remember, when it's the two letters, it's the shortest distance between the 2 points. So they want this one. Well, if we're looking at this, because we have congruent chords, that means that we have congruent arcs. So this arc over here has to be 88 as well. So now to figure out what AB is, we know that all the arcs in a circle have to add up to 360. So if we do 360 minus 88 minus 88 minus 47, that'll tell us what AB is. So put that in your calculator. You get 137. And that is the measure of AB. Alright, let's try some more circle problems. Oh, now we've got some angle examples. These are like the ones that we did yesterday. Okay? Except you're missing a number here. So let's make up a number. Let's make this 22 degrees. Alright, now we can solve it for x. So right here, here's the vertex. It's outside of the circle. So always write the angle equals. And the angle is the one closest to the vertex. That means 22 equals 1/2. And when it's outside of the circle, you end up with two intercepted arcs. And we're going to subtract. And we're going to do big minus small. The biggest is the furthest away. And it actually just looks bigger. So it's going to be 83 minus x. Alright, to solve, we're going to multiply both sides by 2. And when you do that, that leaves you with 44 equals 83 minus x. Okay, so to solve, we'll subtract 83 from both sides. And 44 minus 83 is 39, or negative 39. So we get negative 39 equals negative x. So now we know that x equals positive 39. Alright, let's try another example. Example 8. Got the vertex inside the circle this time. So when it's inside the circle, the angle equals. So the angle is the one close to the vertex. So 63 equals. And when it's inside, you have two intercepted arcs. And when it's inside, you take half the average of the two. So that's going to be x plus 92. So to get rid of the 1/2, we're going to multiply both sides by 2. And that's nice because on the left it on the right it cancels. So 63 times 2 would be 126 equals x plus 92. So to solve, you're going to subtract 92 from both sides. And that leaves you with 34 equals x. Alright, let's try a few more of these. Example 9. Example 9. Here's the vertex. This time it's on the circle. So when it's on the circle, the angle, I was right, the angle equals, and then, well, when it's on the circle, it's going to be half of the intercepted arc. So it's going to be half of 288, which would just be 144. Okay. Both example 9 and 10 have the vertex on the circle. 9, that angle doesn't have a name, but 10 has a name. Because it's made up of 2 chords and the vertex is on the circle, it's an inscribed angle. But because the vertex is on the circle, we know the angle, which is 2x, is going to equal 1/2 of the intercepted arc. And this right here is your intercepted arc, so that's x plus 33. So to solve, we're going to multiply both sides by 2, and that leaves us with 4x equals x plus 33. Subtract x, so we get 3x equals 33. Divide by 3, so x is 11. Okay, 2 more. Example 11, the vertex is on the circle. So when it's on the circle and formed by 2 radii, this is a central angle. And when it's a central angle, the angle equals the arc, which is 4x minus 28. So to solve, we're going to add 28 to both sides. So 124 plus 28 is 152. So we get 152 equals 4x. We divide by 4, so x equals 38. Alright, last example. Example 12. The vertex is right here. It's outside of the circle. So when it's outside the circle, you write the angle equals. And the angle's x because it's closest to the vertex. When it's outside, it's 1/2 of the big arc minus the small arc. Well, they gave us the small arc. That's the one closest to the angle. It's going to be minus 118. What they didn't give us was the big arc, which is this whole thing right here. Well, to find the big arc, we're going to do 360 minus 118. And 360 minus 118 is 242. So this big arc is 242. So now we can finish the problem. So it's going to be 1/2 of 242 minus 118 is 124. And half of 124 is 62. Alright, you get your review worksheet, practice, and you'll be ready for your quiz on Monday.